My name is Georgie and I'm a product manager working on, I'm joined by my colleague Shengjin Du. He's a TME and we kind of focus on programmability, automation, visibility, telemetry, all of these capabilities on an NXOS. And what we're primarily focusing on here is how do you integrate it with open source tooling, and more specifically, what are some of the use cases that you can address? Having the data is great. What do I actually do with it, right? Just a very brief level set, looking at the APIs and the telemetry overview of what is there today. Shengjin's going to go into a demo, like I said, go into the details and the use cases, and hopefully leave some time for Q&A at the end. So just to kind of kick this off, we have the what we call our open programmable APIs, right? So we have the switch and all the switch features at the bottom, talking about interfaces, BGP, etc. And the most common interface into those is what we call NX API CLI. So this is a way to put either a configuration command, or more specifically in this case, a show command into a JSON payload, post it down to the switch, get back an easily parsable key value response that can then be integrated into monitoring toolings and so on. And that's a nice starting off point, but it doesn't quite meet the requirements and the capabilities for kind of what we call our model-based solutions, which are much more efficient and more easily integrated. So the foundation of all of these integrations on NXOS is what we call our DME, our data management engine. So this is a tree-like structure. It has the configuration and the operational state of the switch, and it's got a parent-child relationship. So you would have as an example, you would have BGP, you would have your domain and so on, and you can identify and pick out specific components to get the data from that point in the tree. So this is the data that can be streamed off box without issue. But one of the things that we have seen is that customers are looking for Yang integrations from the switch to integrate with these tools. So there's two types of models. We have our native Yang models and we have our OpenConfig Yang models. The native Yang model is designed to be a one-to-one mapping between that and that DME at the lower level. So it has, again, all the configuration and the state of the switch in this Yang format. Alternatively, we have OpenConfig Yang. So this is designed to be a common interface format across OSs, across vendors. And our stance within our BU is that if the data is available in an OpenConfig model, that's the way you should gather it. There's literally no point to be gathering interface statistics, BGP, CPU, memory, all of this information in a unique way per OS or per vendor. If it's in OpenConfig, take it in that format. Now, OpenConfig at the same time is designed to be common across vendors and across OSs. So it doesn't have all of the capabilities of NXOS. And for that, we say use the native Yang model. Now, we are continuing to work with industry standard partners. We recently added an EVPN model into OpenConfig. So you can now monitor a VXLAN EVPN model or fabric via OpenConfig. But realistically, both are going to be needed for a more broad fabric, to be fair. And all of these are available via various transports into the switch. So we have netconf, restconf, and gRPC or GNMI. Netconf and restconf are primarily used for configuration, and GNMI, gRPC or GNMI is what we're going to primarily be talking about here today. This is where the streaming telemetry components come into it. So it's what we're going to be seeing today is going to be gRPC, GNMI with native Yang and OpenConfig Yang. So that's a very high level kind of overview of the capabilities and the formats that are available on the switch today. Now, telemetry, there's two ways of doing it. There's kind of dial-out telemetry and there's dial-in telemetry. So dial-out telemetry is where all of the configuration or all of the parameters that you want is part of the running configuration on the switch. So you say, what data do I want to gather? How often do I want to gather it? And where do I want to send it? And that's part of the running configuration, and that's applied on the switch. And then the switch initiates that connection outbound to a client. In this situation, it's Telegraph. It could be a homegrown solution. We support gRPC, HTTP, and UDP for this, but we do see the most adoption with gRPC, with GPB, just from an efficiency on the wire standpoint. It is more efficient than other transports and formats. Now, the other way of doing this is with GNMI, and this is the other kind of way of initiating the connection and the configuration. So here, everything with a dial-in subscription, everything is on the client. So it initiates the connection into the switches, and this has the data to collect, how often to collect it, and where to send it. And then the switch sends that information back to the client. So these are really two different operational models. So like one, it's on the switch itself, one is outside. And there's a lot of reasons or you choose one over the other. So one might be you want your switch configuration to be the single source of truth for all of that monitoring. And that's a lot of customers like that and they use that. But that's not a very flexible model either. So if you want to dial up the fidelity of the information that's being gathered, that would require changing the running configuration on a switch. That often goes through an approval process, and that can take days, weeks, longer in some circumstances. So in this situation, the dial-in telemetry might be a more desirable model, but it does mean that there's somewhat of a disconnect between the monitoring and the running configuration of the switch. No one is better than the other. It's all about the operational model that customers have, realistically. It's just looking at some of the capabilities that we added in our more recent releases. We added suppress redundant and heartbeat. This means kind of suppress redundant data. So if the data hasn't changed, don't send me that information. That's essentially to reduce the load on the switch for sending the information, reduce the load on the collector for receiving it, and to reduce the load on the database for storing redundant information. Now, the heartbeat capabilities there, it's a sanity check. So you can say, I want my interface statistics every 10 seconds. But if it hasn't changed, don't send me the information. But you could say every 5 minutes, send me that heartbeat as a sanity check, just to make sure that the connection is still good and I'm still getting fresh information. gRPC tunneling, I'm going to touch on that in a subsequent slide. And then we've also committed to our upcoming 10.4.1 release in Q3 of this year. We're just revving to the latest and greatest version of GNMI. So gRPC tunneling, I mentioned that there briefly. So the model with GNMI is that the client initiates the connection inbound to the switch, and then the switch sends that information. Now, what we have seen is that in some environments, the monitoring infrastructure is separated from the production network via firewall, and that then prevents this client initiating this connection inbound, because opening that port inbound through the firewall is not an easy process to push through. So with gRPC tunneling, it's almost the best of both worlds of the dial-out and the dial-in telemetry. The switch initiates the connection outbound through the firewall. So opening that port outbound is an awful lot easier. And then GNMI can create those subscriptions over the tunnel. So the switch initiates the connection outbound, a tunnel is established, and then GNMI can pass through the firewall via that tunnel.
There are tunnels directly to the clients.
Yeah, so exactly. So the client will initiate it, and GNMI connects through that host and through that tunnel then from there. Absolutely. One last thing, just the architecture for today. This is just one example of what can be done with the data. There are a lot more use cases that can be done. The TIG stack, it's very, very common. It's Telegraph to receive and parse that information. Telegraph has lots of inputs, lots of outputs. We actually worked and committed a GNMI input to Telegraph. It has InfluxDB. It's a kind of a recommended integration coming from the same company, being the database to send the information to, and Grafana for visualization and alerting. This is just one of the integrations that can be done. Telegraph can send information onto Kafka. If you want to put it onto a messaging bus, do machine learning, a whole bunch of different use cases are possible via this. But this is just what we're going to be showing here today. And with that, I will hand it over to Shangjing.
All right, so I will continue from GR. So my name is Shangjing, and I'm also with the product team. We can collect all kinds of data from NexusOS, right? But all this data either is binary or is text-based data. It's really hard for user to interpret or is to get a meaningful result from that, right? So that's why a lot of customer is trying to use the open source framework, and this is one of the most famous stack, which is called TIG stack, Telegraph, InfastDB, and Grafana for visualization. So this is dashboard you can get or you can build by yourself, and by using the telemetry data that you collected from the NexusOS switch. And this is, for example, you can see from the name or from the title, you can see this is collecting from the GMI, from the GMI. So, but actually, we can build exactly same kind of data or same type of dashboard with the layout. And it doesn't matter which way, or it doesn't matter what kind of transport option you are using, you can build a similar dashboard and to visualize the data for user, right? But it's just dashboard. It's fancy or it's just colorful. It's really good to use and put on the screen like this and just monitor our time. But what we can actually get use from the data, that's a really important thing, right? So that's why I wanted to show you some use case that what we can use the dashboard or where we can use all this telemetry data to actually for our day-to-day operation for our daily job. So for example, the first thing I want to show you is, okay, I have some change. I have some schedule change. I do want to make some change on the maintenance mode, maintenance window. And this change has been planning forever in my testing environment, which it should be fine. So I'm going to run my Ansible playbook to make some change. So it's really some simple change, right? It's nothing fancy. And after probably a couple of seconds, and we will see, okay, this change actually made some configuration change to my switch, and it looks good. And so far, I don't have anything like really raised the warning on my dashboard or on any syslog server. But unfortunately, after a certain time, you will see there's a little bit delay for the Grafana to raise the notification. So we can subscribe to the BGP neighborship with onChange, and whenever there's a change on the BGP neighborship, we're going to send the notification immediately. But there's a little bit delay from Grafana to actually detect the problem. So you will see, okay, we actually have a firing alert, which is to say that I have a BGP neighbor, BGP peer is not established. It's red alert. And the source is one of the IP address, and also it's in my user worth red. So we can go to a dashboard and to see what's going on there. We can use a dashboard try to isolate the problem, right? And so we know it's in the worth red. We can see from this time, it's clearly my established BGP neighborship is dropping from 2 to 1. What's going on? I don't know. But at least I can correlate some information at the same time. The route that I learned from the worth red is also dropped significantly. Let's try to correlate some more information to determine that what's going on this box or with this change. So we can also stream not just operation data. We can stream syslog. Basically, you can use the telemetry or GMI to replace your completely data operation to SMP or syslog and with the telemetry. So we can stream syslog here, and basically around the same time, we got notification, hey, my Ethernet 1/12.2 is down because my parent is down. So there must be something happening on this interface. Where is this actually connected to? We have a CB neighborship, and we can see that 1/12 is actually connected to my edge device. Something happened here. I don't know what exactly happened, but at least based on all this information, it's enough for you to isolate the problem, to narrow down the problem to a single device, right? This is notification based. Well, we can troubleshooting. But I can give you a more complex example about how to use the dashboard for troubleshooting. So as a network team, and sometimes we have to interact or we have to work with our server team, right? Eventually, our network is providing the service, providing network service for other server team. So all the time, the server team will come to you and say, hey, on my interface, I'm receiving a bunch of CRC error. It must be coming from your switch, right? I was a tech, and I have been receiving this kind of case all the time. It must be coming from your server because the use receiving is on the ingress direction. But we don't know. We all know that Nexus 9K is actually doing the pass-through forwarding. For the people who are not familiar with the pass-through forwarding, it is actually the way that we're forwarding the packet. Basically, we only receive the first header, then we make the forwarding decision. Basically, when we receive the entire packet on a switch, the packet is already on the wire. It's too late to drop the packet if we receive a CRC error. That means this CRC error actually can be populated from somewhere else. We don't know. On the traditional way, we have to go to login and just show interface counter because the CRC error is not increasing continuously. We have to wait where is this actually happened. But for telemetry data, the good thing about the telemetry is we keep the historical data. We can trace back when the issue actually happened. Right? So for example, this is a case that, hey, I received something from my server team. My server team tell me, hey, I received a bunch of CRC error. It must be coming from your switch. And we at least to start from somewhere, right? And we will tell our server team will give us some information. Well, IP address. I can give you IP address. Where's my IP? Well, the IP address is 10.1.1.40, but just IP address is meaningless to me. I have to allocate, okay, where is this actually connected to? We have all the operational data, that including the routing information, the endpoint information. So we can actually go to my dashboard. I have my preview dashboard, which is collecting all the endpoint. I have my ARP table and a MAC address table. So I can base on my ARP table from entire fabric and search for its IP address, where it's actually learned. 40 from So it's actually learned from two switches. Of course, it's two switches. It's a VPC peer. There's a peer link. Of course, we will learn the ARP from both. But it is actually VPC or is it an open port? I don't know. Let's try to find out again. We have a MAC address here, right? And we can copy the MAC address and search for the based on the MAC address in the MAC address table to see where it is actually learned. So because it's a VPC, because it's a VXLAN EVPN fabric, and we are learning this MAC address all everywhere, as long as the VLAN is deployed there, but at least we have entry. It is learned from one of the front panel on leaf 74.61. Just remember the IP address. It's fun. We get the IP address. We know it is actually coming. It is actually connected to this switch on Ethernet 1/10. So let's first check what's going on that interface. So, well, it's CRC error, and we can base on the counter. And we're collecting all the counter from the open config. And so we can use it. 74.61, and then let's filter based on the open config counter, which is egress error. Let's just first isolate, make sure it is not my SFP problem. It's actually coming from the switch. Well, yes, actually I do have some CRC error on the egress direction. It's alt error, right? I do have something on the egress direction, but it has been stable. I don't know when this actually happened. That is a problem. You cannot really, based on the existing status, it's generating, but I don't know where this is actually coming from or when is it actually generated. So we can trace back. We have timestamp. We can trace back for past 30 minutes. Well, it's not there. Okay, we can trace back a little bit more past hour. Okay, now we know around this time, it is steadily increasing, but not that many, just 10 packets. It's not that many. We can zoom out in time. So it's there. Okay, it's egress, but based on our knowledge, we know 9K do pass-through forwarding. It might coming from somewhere else. Let's check out. We can check out the ingress error packet or ingress FCS error, and also to put them together to see. Hey, you can see that the ingress error on Ethernet 1/48, basically the pattern match the output pattern. Basically, might not be exactly the same, but match. So we can basically isolate the problem is the FCS error or CRC error is actually coming from Ethernet 1/48 on the ingress direction. Where is it? We have a CDP neighbor, right? Remember, we collect a CDP neighbor and we know where this is connected to. So we can go back to our switch 1/74.61. We can go to this dashboard 48. Oh, it's actually my VPC peer. It is coming from my VPC peer. So I know it is coming from here. And this switch is my leaf 2, which is 70. So we can go back to the interface counter and focus on that switch. What's going on with it? So we can go to 70 and the same thing. We know it's a CRC and it's error, so we can just uncheck all other counters, but focus on the error on ingress and egress direction. So we have 70 switches, and about the same time, go back to 1 hour. And now we can see that, oh yeah, go back to 1 hour and FCS error is actually matching the pattern. It's coming on the ingress direction, is actually on the Ethernet 1/10 on this device. So it must be getting from the server that is connected to the Ethernet 1/10 on the 74.70. So we can isolate the problem. Hey, it's not our problem. For network engineer, we're happy. It's just quickly can isolate the problem and to prove network is innocent, right? So that's just how to say. Some quick example, really just a quick example. I come up like 1 week ago, and because we have experienced the use case. For the user, actually, you can set up a lot of alert rule on the Grafana based on the threshold, based on the state change, and based on the rate of the change to raise the notification. This is all open source tools. And with open source GMI telemetry that we implement on NexusOS.
Not a question, I have a comment though.
Sure.
It's really about Grafana, not really about anything else. Is that it's just, it can get unbearable sometimes. Grafana can have a lot of, there's I guess a steep learning curve with Grafana.
It is. Actually, the Grafana itself is, the steep learning curve, it is on the flux, on the query part. On the query, when you want to query the data, whether it's time series data or it is like a single stat, latest single stat, on the query part, it is steep learning. I do agree on that. I do agree.